You wake up November 5th, 2025. Spain, Italy. Observatories point east before dawn. They capture the third interstellar visitor our species has ever tracked. 3I Atlas, fresh from its closest pass by the sun 6 days ago. 203 million kilometers, hot enough to make ice scream into space, and the images come back wrong. A fuzzy ball, compact, glowing, but no tail. No streaming banner of gas and dust pointing away from our star like every comet textbook says should be there. The R-Naves Observatory in Bigorre releases the shot. The Virtual Telescope project in Menciano follows. Same story. A blob where there should be a comet. Harvard professor Avi Loeb sees the images. He runs the math again. Over 13% of this thing's mass should have boiled off during perihelion, 5.5 billion tons minimum. That's not a number you hide. That's not a whisper. That's a cloud visible across millions of kilometers. But the November 5th images show none of it. Loeb publishes his analysis that same day, medium, public. The anomaly count climbs to 10. 3. I Atlas came screaming in from Sagittarius at 61 kilometers per second. Discovered July 1st by the Atlas survey in Chile. Temporary name, A11PL3Z. Within hours, pre-discovery images surfaced. Zwicky Transient Facility caught it June 14th. Already moving, already aimed at the inner system. By July 2nd, 31 observatories had data, 122 observations. The Minor Planet Center gave it the designation, 3I, third interstellar object confirmed, 1I Oumuamua in 2017, 2 I Borisov in 2019, now this, moving faster than both, mass a million times Oumuamua's bulk. Trajectory aligned within 5 degrees of the ecliptic plane. Statistical likelihood, 0.2%, fine-tuned to pass Mars at 30 million kilometers, October 3rd, Venus at 97 million, November 3rd. Hidden behind the sun from Earth during perihelion, October 29th. Closest approach to our planet, December 19th, 269 million kilometers. Never a threat, always a mystery. If you value documented space visitor history and factual comet analysis like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. Also, this script is researched and factual. Using sources from Avi Loeb's peer-reviewed calculations, published November 5th, 2025, on Medium analyzing NASA JPL trajectory data, and direct observatory releases from R-Naves Observatory Spain and Virtual Telescope Project Italy, both published November 5th through 8th, 2025, with imaging timestamps and observation coordinates, plus ICQ Comet Observations Group data, logged November 8th with atmospheric conditions and exposure times documented. Now back to the information. Hubble imaged 3I Atlas, July 21st, 277 million miles out. Teardrop-shaped cocoon, dust coming off the nucleus. Background stars streaked because Hubble tracked the comet's hyperbolic path. That image showed activity. A coma, fuzzy, extended, what a comet looks like when it's warming up. During July and August, something stranger appeared. A sunward jet, an anti-tail, pointing toward the sun, not away. David Jewett and Jane Liu at the Nordic Optical Telescope in the Canary Islands documented it. Not an optical illusion. Not a projection effect. Real material streaming in the wrong direction. By September, that anti-tail flipped. Became a normal tail, pointing away from the sun. The mass loss rate from Webb telescope measurements, 150 kilograms per second at 3.32 astronomical units. Composition, 87% carbon dioxide, 9% carbon monoxide, 4% water. Strange ratios. Low water for a comet. High carbon dioxide. Webb's spectrum published. SphereX data confirmed it. This thing was venting hard months before perihelion, October 29th, perihelion day, 11:27 Universal Time. 1.36 astronomical units from the sun, 203 million kilometers, between Earth and Mars, moving at peak speed, 68 kilometers per second. Solar radiation hitting the surface, 770 watts per square meter. Hot enough to sublimate carbon dioxide ice instantly, hot enough to crack weak structures, hot enough to generate massive outgassing if you're made of volatile ices like every natural comet in our records. GOES 19. Weather satellite tracked it. SOHO watched. Stereo A and Stereo B both locked on. The brightness spiked. Factor of 5 in green band wavelengths, centered at 0.464 micrometers. Blue light, not red. Comets redden when dust scatters sunlight. Their surfaces run cold. 20 times colder than the sun's photosphere at 5,800 degrees Kelvin. so they should look red. 3I Atlas turned blue. 9th anomaly. NASA's Jet Propulsion Laboratory released the non-gravitational acceleration data October 29th, measured at perihelion distance. 2 components. Radial acceleration away from the Sun, 1.1 times 10 to the negative 6th astronomical units per day squared. Transverse acceleration perpendicular to the Sun's direction, 3.7 times 10 to the negative 7th astronomical units per day squared. Standard deviation, 3.7. Robust detection. Davide Farnocchia filed the report. Navigation engineer, PhD from Pisa. He knows orbital mechanics. Non-gravitational acceleration means something pushed this object off a purely gravitational path. For a comet, that push comes from rocket effect, gas venting from the surface, momentum transfer. You lose mass in one direction, you accelerate in the other. Physics, conservation of momentum, no exceptions. Loeb did the calculation. Simple, clean. Non-gravitational force equals mass times acceleration. That force also equals mass loss, rate times ejection velocity. Solve for mass fraction lost. Time at perihelion, 1 month. That's how long it takes to cross 203 million kilometers at 68 kilometers per second. Acceleration, 94 kilometers per day squared. Ejection velocity for thermal molecules at perihelion temperature, 300 meters per second. Plug the numbers. Mass fraction lost equals approximately 13% divided by ejection velocity in units of 300 meters per second. For natural thermal speeds, 13% minimum. Could be higher if the gas moves slower. Could be much higher. 33 billion tons estimated total mass based on nucleus diameter between 0.44 and 5.6 kilometers. 13% of that, 4.3 billion tons. Closer to Loeb's 5.5 billion ton estimate accounting for uncertainties. 5 billion tons of gas and dust. Where is it? November 5th, 6 days after perihelion. 3I Atlas reappears from behind the sun's glare. Morning sky. Eastern horizon, low, maybe 8 degrees up. Our Naves Observatory in Bega, Spain. Ramon Naves runs the operation. He's tracked comets for decades, published observations in professional databases. November 5th. He images 3I Atlas. Exposure details logged. The frame shows a compact fuzzy ball, diffuse coma, maybe a few thousand kilometers across. Sunward direction marked. Bottom left corner. Arrow points anti-sun, the direction where a tail should stream. Nothing there. No obvious cometary tail. Morphology? Not very different from the Hubble image back in July. Before perihelion, before the intense heating, before the 13% mass loss the math says must have happened. Same day. Virtual telescope project. Manciano, Italy. Gianluca Massi operates the facility. Multiple robotic telescopes. Celestron C14, Paramount mount, SBG camera. He takes 2 120-second exposures, unfiltered. Conditions? Terrible. Almost full moon setting. Target just 8 degrees above the eastern horizon, nautical twilight approaching, sun 12.2 degrees below horizon. Despite that, the image resolves. 3I Atlas shows its coma. Diffuse, cometary nature, obvious from the fuzzy halo, but again, no clear tail structure. Massi notes the bright star southwest of the comet, Gaia designation DR3. 3634786807779951232. Magnitude 11.76, a reference point. The comet looks similar. Maybe magnitude 11, faint but detectable. Loeb sees both images. November 5th, he compares them to Comet Lemon, solar system comet, also visible that week. Our Naves imaged Lemon November 3rd, same observatory, same equipment. 2 days before the 3I Atlas shot. Lemon shows a clear cometary tail, textbook, streaming away from the sun, dust and ions pushed by solar radiation pressure and solar wind. Exactly what you expect. Loeb publishes on Medium. Title: No clear cometary tail in post-perihelion images of 3I Atlas. Timestamp: November 5th, 2025. He lays out the math, the expected mass loss, the comparison to Lemon, the 10th anomaly, no massive coma. No visible tail. Something's wrong. The image is spread. Social media erupts. Where did the tail go? Is this even a comet? Alien spacecraft confirmed. The speculation machine fires up. But hold on. Geometry matters. Viewing angle matters. When a comet's tail points nearly toward or away from Earth, you might not see it edge on. Foreshortening. The tail exists, but looks compressed. Could that explain it? Loeb considered that. He ran the numbers on geometry. November 5th, 3I Atlas sat at specific coordinates. Solar elongation measurable. Viewing angle from Earth relative to the Sun-comet line, not edge-on, not compressed. The tail, if present and massive as predicted, should be visible. Other comets at similar geometries show tails. Lemon proved it. Same time frame, same instruments, different result. November 6th. Massey images again, 6 60-second exposures. Unfiltered, Celestron, C14. Moon still bright, 71% phase. Target 10 degrees above eastern horizon. Astronomical twilight. Sun deeper below horizon now, minus 12.2 degrees. The coma remains obvious. Diffuse sphere. Evidence of cometary nature, but still no extended tail structure visible in the stacked frames. November 8th. Everything changes. Michael Yeager, Gerald Riemann, Enrico Prosperi, ICQ Comet Observations Group. They catch 3I Atlas at 29 degrees solar elongation. Higher in the sky, 7 to 10 degrees above the eastern pre-dawn horizon. They stack 24 green filter exposures, each 35 seconds. 2 red filter frames, 2 blue filter. Combined image processing. What emerges? A complex jet structure, at least 7 distinct jets. Material streaming outward in multiple directions, some pointing sunward, anti-tails, some pointing away. The glowing halo extends 500,000 kilometers, 5 arc minutes on the sky. Twilight interfered eventually. Bright moonlight washed the field, but they got the data, mountain location, clean air, good seeing. Loeb sees the November 8th ICQ images. He publishes again. Medium, November 8th. A complex jet structure emanates from 3I Atlas after perihelion. The jets change everything, not about whether mass is escaping, about how much and where it's going. 7 jets in different directions, random outgassing pattern. If the non-gravitational acceleration came from cometary venting, and you've got jets firing in many directions, only a fraction of the ejected mass carries excess momentum in one preferred direction, and the rest cancels out. Random walk, no net push. That means the total mass loss must be much larger than 13%. Could be 20, 30, 40%. The cloud of debris around 3I Atlas must represent a substantial fraction of its initial mass. For a natural comet, that's extreme but possible. For a technological object with directional thrusters, also possible. Ambiguity remains. November 9th, British Astronomical Association. Observers, Michael Buchner and Frank Niebling, 2 telescopes, composite processing. The image 3I Atlas showing a long smoking tail. Finally, extended structure. Plus 2 anti-tail jets. The multi-jet morphology persists, complex. Unlike typical comets with one smooth tail pointing anti-sun, this thing sprays material everywhere. Loeb comments on the BAA images. Remarkable target for future Hubble and Webb observations. Closest approach to Earth coming December 19th, 269 million kilometers. Best observation window, November 10th, virtual telescope project. Images again. Gianluca Massi, 14 122nd exposures, Sigma clipping combination, RTEC 250 telescope, Paramount mount, C3 Pro 61,000 camera, target 12 degrees above eastern horizon. Moon at 71% phase, 85 degrees away, good separation. The image reveals an ion tail, clear structure, extending away from the nucleus. Why visible now, but not November 5th? Geometry. As the comet moves northward in Earth's sky, the viewing angle improves. The tail that was behind the nucleus is seen from Earth at perihelion becomes more edge-on, better visibility. The tail existed all along, just hidden by geometry. Massi explains this, straightforward, observational astronomy 101. But wait, if geometry explains the lack of visible tail, November 5th, why did Loeb raise the alarm? Because the expected mass loss was so large that geometry shouldn't hide it completely. 5 billion tons of ejecta forms a huge cloud, scattering sunlight, visible from many angles. Comet Lemon, observed same time frame, showed a tail despite its own geometry. The question isn't whether 3I Atlas has a tail. November 10th proves it does. The question is whether the tail is massive enough to account for 13+% mass loss, and whether the November 5th images, showing essentially no extended structure, match expectations for a natural comet that just lost 5 billion tons. Let's talk numbers. Coma diameter observed November 5th. Maybe 5,000 kilometers from the R Naves image. Fuzzy ball. That's surface brightness distributed over the coma area. How much dust and gas does 5 billion tons spread across 5,000 kilometers? Depends on particle size distribution, depends on scattering efficiency, depends on viewing geometry and phase angle. But order of magnitude? You should see something more than a compact blob. Comets observed post-perihelion typically show extended comas, broad halos, streamers. 3I Atlas on November 5th looked more like a distant galaxy, soft glow, no structure. China National Space Administration released images November 6th. Their Tianwen-1 Mars orbiter caught 3I Atlas during its October approach to Mars. High-resolution imaging camera, HIRIC. The orbiter passed within 18,000 miles, 29,000 kilometers. Close. The released images show the nucleus and surrounding coma, diameter several thousand kilometers, but details limited. Image processing shows some structure, but nothing definitive on tail morphology. Tianwen-1 provided context, confirmed the object's activity, but didn't resolve the tail question for the critical November 5th timeframe. NASA's Mars Reconnaissance Orbiter also imaged 3I Atlas. October 2nd and 3rd, HiRISE camera, high-resolution imaging science experiment, 3 times the resolution of Hubble's July images. But those images remain unreleased as of November 10th, 2025. Federal government shutdown, bureaucratic hold. Representative Anna Paulina Luna from Florida sent a letter to NASA Interim Administrator Sean Duffy, urging release. This information is of great importance to advancing our understanding of interstellar visitors and their interaction with our solar system. Luna tweeted November 6th, "Good conversation with NASA. Images will release when government reopens. Cannot release during shutdown due to bureaucratic reasons. The high-rise images could show nucleus detail, surface features, jets at high resolution, critical data, locked behind red tape. ES's Mars Express and ExoMars Trace Gas Orbiter both observed 3I Atlas during the October Mars flyby. ExoMars TGO released an image, described as slightly fuzzy white dot, no visible tail structure in that frame. But distance and instrument limitations matter. Mars orbiters weren't designed for comet imaging. They got bonus data, not primary mission. The evidence converges on a timeline. July 21st, Hubble shows teardrop coma. Activity present, July through August. Anti-tail sunward. Documented. September, tail flips. Becomes normal. Points away from sun. Mass loss rate 150 kilograms per second, measured by Webb. October 29th, perihelion. GOES 19, SOHO, stereo spacecraft track. Brightness spike. Blue color, anomalous. Non-gravitational acceleration detected. November 5th, first post-perihelion ground-based images. Compact coma, no clear tail. November 6th. Similar. November 8th, complex jets appear. 7 directions. November 9th, extended tail visible. November 10th, ion tail clearly imaged. The discrepancy lives between theory and early observation. Theory says 5 billion tons. November 5th says compact blob. November 8th through 10 say jets and tail. Did the mass loss happen later? Delayed outgassing? Thermal wave penetrating into the nucleus after perihelion? Possible. Comets don't outgas uniformly. Subsurface ices heat slowly. Hours to days for thermal diffusion. But the non-gravitational acceleration was measured at perihelion, October 29th. That requires mass loss during perihelion passage, not days later. Qiqing Zhang at Lowell Observatory captured the first optical post-perihelion image October 31st. Halloween. Discovery Telescope in Arizona. 4.3 meter mirror. One of the largest scopes that could point low enough to catch 3I Atlas right after perihelion. Morning twilight. Comet just above northeastern horizon. Sun still below. Narrow observation window. Zhang's image showed the comet. Bright dot. Diffuse. But no extended tail structure visible in that frame either. Zhang posted to his blog November 2nd. Noted that standard amateur telescopes should start detecting it. 8-inch aperture minimum. Clear sky. Very low eastern horizon. It won't look very impressive, just a smudge, but an increasingly visible smudge over the next few days. Zhang imaged again November 7th with different filters, multiple frames. The diatomic carbon filter showed green glow, C2 emission. That's carbon molecules fluorescing in sunlight, common in comets. The greenish tint matches predictions, sublimating carbon-rich ices, but again, early November images from Zhang and others showed compact morphology. The extended tail structure emerged later as geometry improved and possibly as delayed outgassing continued. Physics check. Carbon dioxide sublimates at lower temperatures than water ice. At 3, I-Atlas's perihelion distance. CO2 ice crosses sublimation threshold easily. Water ice? Harder. You need higher surface temperatures or deeper solar heating. The web data said 87% CO2, 4% water. That composition profile means CO2 drives the outgassing. Fast, efficient, but also CO2 produces less dust than water-rich comets. Water ice binds to dust grains. When water sublimates, it drags dust, big visible coma, lots of scattering. CO2's cleaner, more gas, less dust. Could the low dust content explain the weak visibility? November 5th. High gas output, but low dust to gas ratio means faint scattered light. Ion tail might be bright in emission, but dust tail weak. Possible. But Loeb's calculation doesn't depend on dust. It depends on mass. Gas has mass. 5 billion tons of carbon dioxide gas. At what density does that become visible? Molecular column density needs to reach a certain threshold for scattering cross-section to show up. Spread 5 billion tons across a spherical shell expanding at 300 meters per second over 6 days. Shell radius, 155 million meters, 155,000 kilometers. Volume, enormous. Density drops. Scattering signature weakens. But still, comets with similar mass loss rates show visible extended structure. The November 5th puzzle remains. Alternative explanation, the mass didn't leave as diffuse gas. It left as discrete chunks. Fragmentation, 3. I-Atlas broke apart near perihelion. Thermal stress, spin up from asymmetric outgassing. Comets fragment, Shoemaker-Levy. 9 tore into pieces before hitting Jupiter in 1994. Gravity shredded it. 3. I-Atlas wasn't close enough to the Sun for tidal breakup, but thermal stress? Possible. If the nucleus fractured, you'd get several smaller pieces, each outgassing independently. That creates jets in multiple directions. November 8th image shows exactly that. 7 jets, could be 7 active fragments or regions, but fragmentation should show up as separated nuclei, multiple bright points. The November images show a single compact core. No obvious splitting. Zhang at Lowell looked for small objects associated with 3 I-Atlas, found nothing clear. ESA's ExoMars images from October, faint features around the comet, but likely noise artifacts, no verified branched objects. If 3 I-Atlas fragmented, the pieces stayed close, within the coma, not resolved. Another alternative, the non-gravitational acceleration came from something other than outgassing, radiation pressure on a reflective surface, light sail. Solar photon momentum pushing an artificial structure. But radiation pressure acceleration scales with surface area to mass ratio. For 3 I-Atlas's estimated mass and size, radiation pressure contributes negligible acceleration compared to the measured values. You'd need a huge surface area. Thin membrane, not a compact nucleus. Observations show compact nucleus. No extended structure that could catch photons efficiently, or consider directed thrust, engine. Artificial propulsion, exhaust velocity much higher than thermal speeds, thousands of meters per second instead of 300. Higher exhaust velocity means less mass needed for same acceleration. Instead of 13%, maybe 2 or 3%, that would produce a much smaller gas cloud, harder to see. Fits. November 5th observation. But where's the heat signature? Engines run hot, infrared bright. Webb looked, infrared observations. Found cold comet signature, carbon dioxide sublimation, no hot exhaust plume, no engine glow. The data fights itself. Non-gravitational acceleration says mass loss. Prediction says 5 billion tons. November 5th says, where is it? November 8th says, here it is, scattered in 7 directions. November 10th says, now we see the tail. The timeline suggests delayed visibility due to geometry and possibly continued outgassing post-perihelion. But the November 5th null detection bothers some researchers. Bothers Loeb enough to call it a 10th anomaly. Independent observations for context. Comet Lemon, C2825, a 6. Solar System Comet, visible same time frame. R. Naves imaged it. November 3rd, clear tail, anti-solar direction, textbook morphology. Magnitude similar to 3 I-Atlas. Geometry different, but not radically so. Lemon proves that ground-based telescopes in early November could resolve cometary tails. Atmospheric conditions allowed it. Equipment functioned. 3 I-Atlas. Just didn't show the same structure. Why? Different composition explains part. Lemon, likely water-rich. Standard solar system comet. Water ice sublimates slower than CO2. But water drags more dust. bright visible tail. 3I Atlas, CO2 rich, water poor, less dust, fainter tail, but mass loss still happened. JPL's non-gravitational acceleration data proves it. Momentum left the system. Gas carried it away, somewhere, somehow. Loeb raised the question not as conclusion, but as puzzle. He didn't claim proof of artificiality. He said the observations don't match expectations for a natural comet with massive evaporation. That's a discrepancy worth noting. Worth investigating. Science proceeds by noting discrepancies. The November 5th images matter because they capture the earliest post-Perihelion moment. Fresh from peak heating. If you're going to see massive outgassing, that's when... And it looked quiet, compact, unimpressive. Then, days later, jets appear. Tail becomes visible. Geometry improves. Or outgassing continues. Or both. Future observations will clarify. December 19th, closest approach to Earth. 167 million miles. 269 million kilometers. Hubble can observe. Webb can observe. High resolution, detailed spectra, morphology, jet structure, composition, dust-to-gas ratio, thermal profile. The observations will either confirm natural comet behavior with unusual composition or reveal something stranger. ASA's Jupiter Icy Moons Explorer, JUICE spacecraft, currently en route to Jupiter. Passed within 64 million kilometers of 3I Atlas, November 4th. Instruments include JANUS visible imager, MAGIS infrared spectrometer, SWI submillimeter wave instrument, JUICE observed, data recorded, but downlink delayed. Spacecraft bandwidth limited. Distance from Earth, large. Full data release expected February 2026. That's 4 months away. Patience required. But JUICE data will include close-range observations during the active post-perihelion phase. Complements Hubble and Webb, adds 3-dimensional perspective, different viewing angle, different instruments. If you value space, object monitoring, and factual observational astronomy like this, subscribe. We dig through observatory releases and peer-reviewed calculations to show you what actually happened versus what was predicted. Comment from which city you're watching. Now back to the story. The physics demands accounting. 5 billion tons don't vanish. They go somewhere. They reflect light or emit light or absorb light. They interact with solar radiation. They scatter photons. Molecules fluoresce. Ions glow. Dust shines. The question is detection threshold. What brightness constitutes no clear tail? The R-naves and virtual telescope images. November 5th, show diffuse coma. Faint halo. That's outgassed material, just not extended tail structure, not streaming banner, not cometary flourish. Could the entire 5 billion tons fit inside a 5,000 kilometer coma? Density check? 5 billion tons equals 5 times 10 to the 12th kilograms. Spread evenly through a sphere 5,000 kilometers diameter. Volume equals 65 times 10 to the 18 cubic meters. Density equals 7 times 10 to the negative 8 kilograms per cubic meter. 7 times 10 to the negative 11 grams per cubic centimeter. That's incredibly tenuous. Barely above lab vacuum. Column density through the coma. Maybe 10 to the 16 molecules per square centimeter depending on molecular weight. For carbon dioxide, that's optically thin. Low scattering. Faint glow. Marginal detection. So maybe the math works. 5 billion tons present. Spread diffusely. Low dust content. CO2 rich. Faint scattered light. November 5th images catch it as barely resolved diffuse coma. Not zero detection. Just no obvious extended tail. That interpretation reconciles the numbers with observation. Not a paradox. Just a threshold issue. Observers expected dramatic visible tail. Got subtle diffuse glow instead. Lesson? Interstellar comets with unusual composition fool expectations. But Loeb's concern remains. Compare to Lemon, similar brightness, similar distance from Earth, different composition, but Lemon shows clear tail. If composition alone explained it, why didn't other CO2-rich comets also show suppressed tails? Historical data, C 2016 R2, long-period comet, extremely rich in carbon monoxide and nitrogen, poor in dust. ICQ observers noted. November 8th, that 3I Atlas jets resemble C 2016 R2's tail structure. The comet also showed unusual morphology, complex jets, low dust, so precedent exists. Unusual composition creates unusual appearance. 3. I Atlas fits the pattern. Natural comet, strange composition, atypical behavior, but natural, except for the other anomalies. Ecliptic alignment, 0.2% likelihood. Sunward anti-tail in July, August, not optical illusion. Real, million times more massive than Oumuamua, 1,000 times more than Borisov, faster than both, 0.1% likelihood. Arrival time, fine-tuned for Mars, Venus, Jupiter, close passes, 0.005% likelihood. Nickel-enriched coma, orders of magnitude above normal comets, 4% water instead of 80. Extreme negative polarization, unprecedented. Arrival direction, within 9 degrees of 1977 WOW signal. Blue color at perihelion instead of red. Non-gravitational acceleration, requiring massive evaporation, but November 5th, showing no clear tail. 10 anomalies, stack them, multiply the probabilities. What's left? Either we're witnessing a statistically unlikely but natural comet with multiple rare properties, or something else. Loeb doesn't claim to know. He quantifies uncertainty using the Loeb scale. 0 equals definitely natural. 10 equals definitely technological. 3, iAtlas ranked 4 before perihelion. After the November observations, still analyzing. If December observations show classic cometary features, the rank drops. If they show continued anomalies, rank stays or rises. Science proceeds by measurement. The November 5th images matter as data point. They don't prove anything alone. Combined with other observations, they contribute to the puzzle. R. Naves Observatory published the frame. Time stamp, coordinates, exposure settings, transparency. Virtual Telescope Project did the same. ICQ Group documented their November 8th observations, equipment, filters, stacked exposure counts. British Astronomical Association logged November 9th. Lowell Observatory published October 31st. Professional and amateur astronomers worldwide contributed data. That's how science works. Many eyes, many instruments, cross-checking, verification, independent confirmation, the narrative that emerged. 3, iAtlas showed compact morphology immediately post-perihelion. November 5th through 7th. Low surface brightness coma. No extended tail visible in early images. November 8th, complex jets appeared at higher solar elongation. November 9th, extended tail structure visible. November 10th, ion tail clearly resolved. Progression suggests geometric and temporal factors. Viewing angle improved. Outgassing continued or became more visible, or both. The discrepancy between predicted massive cloud and observed compact morphology. November 5th invites explanation. Proposed explanations. Unusual composition with low dust-to-gas ratio. Delayed outgassing from subsurface reservoirs. Geometric suppression of tail visibility. Fragmentation into multiple pieces, creating complex jet pattern. Or technological nature with directed thrust and low mass loss. Each explanation fits some data. None fits all data perfectly. More observations needed. Therein lies the scientific process: prediction, observation, discrepancy, hypothesis, test, repeat. 3. iAtlas provided prediction. 13% mass loss, 5 billion tons ejecta. Visible cloud. Observation provided data. November 5th, compact coma. November 8th, complex jets. November 10th, visible tail. Discrepancy identified. Predicted massive cloud versus observed compact morphology. Hypothesis generated. Low dust, CO2-rich composition, geometric effects, delayed outgassing, test coming, December observations, high-resolution Hubble and Webb data, JUICE spacecraft measurements, February 2026, the November 5th evidence stands, R. Naves frame, virtual telescope frame. Both show 3, iAtlas as fuzzy ball, compact, coma present, tail not clearly visible, context. 6 days post-perihelion, expected massive evaporation, expected visible tail, neither clearly evident. That's the evidence. That's what the images show. Interpretation, debated. Loeb sees anomaly, others see geometry and composition. Resolution awaits better data. Worth noting, no fraud, no hoax, no conspiracy, multiple independent observatories, different countries, different equipment, same result. November 5th, compact morphology, no clear tail. Then later, images showing jets and tail as geometry improved. Legitimate scientific puzzle, not manufactured controversy. Also worth noting, 3, iAtlas remains accessible. Magnitude 11 through 12, 8-inch telescope minimum. Clear sky, low eastern horizon before dawn. November, rising in Virgo, moving toward Leo in December. Brightness, fading as distance increases but still detectable. Amateur astronomers contributing observations, adding to the database. Citizen science in action. You can observe this object. You can verify the claims, point your scope, check the coordinates, see for yourself. That's the democratic nature of astronomy. Universe is public. Data is shareable. Technical detail on the R Naves Observatory frame, located Begur, Spain, automated system, APO refractor, CCD camera, exposure likely tens to hundreds of seconds. Sky conditions, November 5th, moonlight, twilight, horizon glow. Challenging but sufficient for detection, image processing standard, dark frame subtracted, flat field corrected, stacking if multiple exposures, calibration verified. The frame shows comet centered, sunward direction marked with arrow. Scale indicators present, that's professional observatory practice. Documented, reproducible, virtual telescope project frame similar, Manciano, Italy, Gianluca Massi's facility, multiple telescopes available. Celestron C 14 used for this observation, Schmidt Cassegrain design, 356mm aperture, SPIG CT10 camera, CCD chip, cooled, low noise, 2 120-second exposures averaged, unfiltered. Broadband, captures all visible wavelengths, bright moon nearby, poor conditions, but image quality sufficient, coma visible, structure obvious, tail, not in that frame. Compared to November 10th, virtual telescope image, same location, different telescope, Artec 250, larger aperture, 635mm, C3 Pro camera, 14 exposures, Sigma clipping combination, advanced processing, removes outliers, cosmic rays, satellite trails, noise. Result, cleaner image, ion tail visible, extended structure. Why the difference from November 5th? Better equipment, better conditions, better geometry, temporal change, or all of the above. Lobes calculation transparent. Published formula, mass fraction lost equals perihelion time, times acceleration divided by ejection velocity. Perihelion time, 1 month, acceleration 94 kilometers per day squared, ejection velocity 300 meters per second. Plug and solve, 13%. Show your work. Anyone can verify. That's science, not assertion. Calculation. If you disagree, show where the math fails. Otherwise, the number stands. JPL's non-gravitational acceleration measurement also transparent. Orbit determination based on 4,022 data points, 227 observatories, astrometric positions, fitted trajectory, residuals computed. Gravitational model subtracted. Sun, planets, moons, all accounted for. Leftover acceleration, non-gravitational, 3.7 standard deviations, statistically significant, not noise. Real effect, published NASA JPL report. October 29th, accessible, verifiable, the chain of evidence holds, acceleration measured, mass loss calculated, massive ejecta predicted. November 5th, images show compact coma, discrepancy identified. Later images show jets and tail, partial resolution, full resolution pending. That's where we stand. November 10th, 2025, data in hand, more data coming, interpretations competing, science proceeding. One more detail. Avi Loeb's motivation, he heads the Galileo project, searches for technological signatures from extraterrestrial intelligence, former chair, Harvard Astronomy Department, published researcher, provocative thinker. Accused by some of sensationalism, defended by others as rigorous, his Loeb scale quantifies agnosticism, not jumping to conclusions, but not ignoring possibilities. He scored 3 IATLAS rank 4, ambiguous, could be natural, could be technological, data insufficient to decide. That's honest, that's scientific. Critics say Loeb cries alien too often. His response, we should look, we shouldn't assume. Absence of evidence isn't evidence of absence. 100 billion stars in our galaxy, hundreds of billions of galaxies. Technological civilizations likely exist. Their artifacts might pass through our system. We should check. 3 IATLAS offers rare chance. Interstellar visitor. Large, bright, observable. Close approach. Let's study it thoroughly. Let's not dismiss anomalies prematurely. Reasonable position. Supporters say Loeb asks the right questions. Science stagnates when it stops questioning. Anomalies matter. They reveal new physics, new phenomena, new understanding. History proves it. Neptune discovered because Uranus's orbit didn't fit. Dark matter inferred because galaxies rotate wrong. Quasars mystified until we understood supermassive black holes. Anomalies lead to breakthroughs. 3. IATLAS shows anomalies. Study them. Learn. The November 5th evidence stands as inflection point. Before, we expected massive post-perihelion activity. After, we saw compact morphology. The gap between prediction and observation forces us to think harder, refine models, question assumptions, consider alternatives. That's the gift 3 I-Atlas brings. Not just data, questions. And questions drive science forward. Final technical note. The comparison between 3 I-Atlas and Comet Lemon matters. Both visible early November. Both imaged by R. Naves Observatory. Both magnitude 10 to 12. Both in morning sky. Lemon shows clear tail. 3. I-Atlas doesn't. November 5th frame. Control experiment. Same observer, same equipment, same atmospheric conditions. Different targets, different results. That isolates the difference to the objects themselves, not observational bias, not equipment failure. The comets differ. Lemon behaves normally. 3 I-Atlas surprises, or does it? Later, 3 I-Atlas images show tail. November 10th, clear ion structure. So the comet has a tail after all. The November 5th frame just didn't show it clearly. Why? Geometry, most likely. Viewing angle. Tail behind nucleus from Earth's perspective. Edge on, foreshortened, hard to see. That explanation works. That explanation is mundane. That explanation lets us sleep at night knowing the universe behaves as expected. Except the other 9 anomalies, except the statistical improbabilities, except the sunward anti-tail, except the blue color, except the nickel enrichment, except the wow signal alignment. Stack them up. 9 coincidences. 10 if you count November 5th, compact morphology before geometry improved. How many coincidences before you consider alternatives? That question lives in the gray area between data and interpretation, between measurement and meaning. Between what we observe and what we conclude, science inhabits that gray area. Comfort in uncertainty, rigor in questioning, honesty in admitting we don't know. Yet, December 19th approaches, closest approach. 269 million kilometers, multiple telescopes ready, Hubble scheduled, Webb scheduled, ground-based networks coordinated, data will pour in, spectra, images, photometry, polarimetry, composition refined, structure resolved, behavior modeled, then we'll know more. Then the November 5th evidence will fit into larger context. Then we'll see whether the compact morphology was geometric fluke or meaningful anomaly. Until then, we have the images, R. Naves frame, virtual telescope frame, November 5th, 2025, 6 days after Perihelion. Comet 3, I-Atlas, interstellar visitor, third of its kind, compact fuzzy ball, no clear tail. Expected massive ejecta, visible or not, that's the evidence, that's the question. That's why we watch the sky. Because sometimes the universe surprises us. Sometimes the comets don't read the textbooks. Sometimes the evidence matters more than expectations. And always, always, we keep observing, we keep measuring, we keep asking. That's how we learn. That's how science works. One frame at a time, one calculation at a time, one observation at a time. November 5th gave us a frame. The math gave us a prediction. The gap between them gave us a puzzle. The solution, still forming, still unfolding, still waiting in the dark between stars. Where 3, I-Atlas came from, where it's heading, what it really is. We don't know yet, but we will. We're watching. The telescopes track it. The data accumulates. The truth assembles itself from photons captured, numbers calculated, images compared, minds questioning. That's the process. That's the method. That's the reason the November 5th evidence matters. Not because it answers everything, because it asks the right questions. And in science, asking the right questions is half the battle. And the other half? Waiting for the universe to answer. December 19th. Mark your calendar. The universe speaks slowly, but when it does, we listen.